We were unable to finish off the last two problems from your notes, and so I want to make sure we quickly do those. And then we move on to kind of our last lesson before we get a little bit of a break. So tomorrow you will have a full work day to work on really what today's assignment is, or to get caught up on anything else. Hopefully that'll go well for you. And so these model the last two problems that you have in your assignment. I'm sorry I forgot to tell you not to really try those even yesterday, but here's where we are at. The first time, these are not that important. Why do I have them as part of this? Because I saw them on the ACT practice test one time, and I got them wrong. Okay, so I'm telling you right now, the first time I saw it, I did it incorrectly. Here's what I did. I said negative 2 times negative 50 is 100, and the square root of 100 is 10. Look reasonable? That's not the answer. And so it is the case that if you see a negative underneath the square root, you need to express it in its complex form first. So everybody agree I could factor out a negative 1, and that'll become I roots of 2. So I roots of 2 times I roots of 50. Now, as we multiply this, I have I squared roots of 100. I squared is negative 1, and the square root of 100 is? So I get negative 10. Do that? So similarly for the next one, as I multiply this out, first I must extract the imaginary portion. So I have a 1 plus I roots of 3 times 2 minus I roots of 5. I'm going to go ahead and FOIL this out. 1 times 2 is 2. 1 times negative I roots of 5 is negative I roots of 5. 2 times I roots of 3 is 2 I roots of 3. And how would you write I roots of 3 times I roots of 5? How would you write that? I squared roots of 15. Thank you, Evelyn. And what is I squared? Does everybody agree that this last piece here is simply just going to turn to a plus root of 15? And so, as we write things in complex form, a plus bi, notice that you have a real part and you have an imaginary part. So my real parts are going to be the ones that are underlined in red, or 2 plus the root of 15. Okay? That's the real part. The imaginary parts are the ones that I underline in green. Or in other words, plus 2 I roots of 3 minus I roots of 5. And so technically how this would be expressed on the ACT, if they chose to express this, is notice how the I sits at the end of B. They would write this as 2 plus the root of 15. That's your real part. And your imaginary part would be 2 roots of 3 minus the root of 5 times I. Notice how I sits on the end. So I have my real part, I have my imaginary part. That's how they do it. There's really no application of this for us moving forward, so I don't have a ton of problems like that, but I do say that if there's things that are on the ACT, I make sure that we cover it. Yeah.
So it's wrong if I have the eyes on the inside?
No, I wouldn't mark it wrong. I just want you to know that the ACT would put it there. Okay? Okay, so one of the best lessons of the year, one of my favorites. But before we begin, tell the person next to you, how caught up are you in your homework? Go. How caught up are you in your homework?
I started it and it's like
So now we can take everything that we've had and we can put it together into this beautiful piece. And for me, this is the coolest thing about algebra. This is what I wait all year to teach in this class. Literally, of the semester, this is my favorite thing. I think that this summarizes what we want to know about algebra perfectly. This is what I use moving forward in my life within calculus and other things like that. But every polynomial of degree n has exactly n solutions. So this one has degree 4, so it has 4 solutions. It would be great if we could just say that, but there's other pieces we would like to say with it. And one thing that we'd like to say with it is that if a polynomial has a coefficient of a, every single polynomial can be written of this form. A times, and the solutions to the polynomial are c sub 1, c sub 2, c sub 3, so on and so forth. So it can be factored to x minus c sub 1, x minus c sub 2, x minus c sub 3, x minus c sub n, for those n solutions. So the fundamental theorem of algebra doesn't say just one thing, it says 2 things so far. It says that if a polynomial has degree n, it's going to have n solutions. And the second thing, it says that every single polynomial can be written in factored form. And that's interesting because we spent a whole lot of time finding new ways of factoring, right? When we do the rational roots theorem, that is simply just a new way of factoring, making good guesses. If you notice, I continually write the final answer in factored form a lot, don't I? That's for this purpose, and you'll see it today. And then finally, there's this last piece. And this is quite interesting. Hopefully you've noticed it. You've been able to build some anticipation for this. But is it possible that these 4 solutions, that some of them are not real? If they're not real, then they would be imaginary. And remember, we account for that. For example, we say, hey, it might have 5 solutions or 3, or we subtract by, why do we subtract by 2? And it's for this reason. If a polynomial has a solution of a plus bi, meaning that has a complex solution, then another solution must be a minus bi. Meaning that there's never just one complex solution. It would always come in pairs. There would always be 2 of them. Think about the quadratic formula, right? Suppose you had 3 plus or minus the square root of negative 7 over 2. Notice that this is going to produce an imaginary solution, right? Well, you have the plus and the minus. You have 2 there. The imaginary will never come as a single. It will always come as a pair. And knowing that, you are now ready to see the exact kind of problems that you'll be expected to do on the test, just a little bit more than what we saw yesterday. And so, we have the following. We want to identify the total number of complex roots. We want to be able to identify the number of positive real, negative real, total real, the imaginary, our rational root choices, our solutions, and finally, if we can, we'd like to write in factored form and maybe even graph it.
What is the second to bottom one say?
Rational root choices. So we're going to take this step by step and we're going to make it very, very simple, okay? Too many times people don't focus on this lesson and they only focus on the study guide and it costs them points. So these problems are picked out very, very specifically in this scenario. The number of complex solutions is always that. That means we have 4 total solutions. That's the combination of the real and the imaginary. How do I determine the number of positive real? How many sign changes are there? There's 1. That means there is 1 positive real, exactly 1. There can't be less, there can't be more. We know there's exactly 1. How would I determine the number of negative real? Yeah, I do p of negative x, and x to the 4th will not change, will it? And neither will my 16. P of negative x is the same thing, so there is 1 negative real. Not 0, not 2, not any more, not any less. There is exactly 1. So if there's exactly 1 positive real and exactly 1 negative real, then how many total real are there?
2.
Or 0.
No. Wait, really?
No. And this is the important piece. Does everybody agree if there's 1 positive and 1 negative, there has to be exactly 2?
Yes.
There must be exactly 2. So in that case, we don't subtract 2 from it because it says there's exactly 1 and 1. So we know there's 2. There's no less. Everybody got that? Great. So we always use this combination to come up with this. We don't just automatically subtract 2 off the total real. We always use the combination of the positive and negative to come up with that guy. Well, if there's 2 that are real and there's a total of 4, then how many imaginary are there?
2.
There's exactly 2 that are imaginary. If I use the rational roots theorem, I would take my p's divided by my q's. And I would have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. And you may want to go that route. I don't want to go that route. What am I going to do instead? Factor. Because it factors quite nicely, doesn't it? And how do you factor x to the 4th minus 16? Great. Does that factor again? Yeah. Because 0 is equal to x plus 2 times x minus 2 times the x squared plus 4. Sum of squares does not factor. You do that on a test. I take my spoon, I stab it into my eye. Don't factor the sum of squares. Well, there's a caveat to that. I'll show you in a second. So that means we have solutions of what? Positive, negative 2. So those are 2 of my solutions. And now I have to find 2 more. This does not factor, so I solve x squared plus 4 is equal to 0. I will subtract the 4, and I'll take the square root. And I get x is equal to plus or minus 2i. Before we write it in factored form, let's look at what we got here. It says 1 positive real. There it is, positive 2. It says 1 negative real. There it is, negative 2. It says that there's a total of 2 real, which are right there. It says that there's 2 imaginary, which are right there, for a total of 4. And those choices are also sitting right there. We've diagnosed everything ahead of time. What a great way to check my answer. Does it look like I got this right?
Yeah.
Absolutely. And then finally, we complete the, we said if there's 1 imaginary solution, there'll be another. We've got it right there. It says to write it in factored form. So this all does factor. You don't have to write it like this. I'm only going to do this once. X minus 2, x minus negative 2, x minus 2i, x minus negative 2i. The fundamental theorem of algebra says you can write everything as x minus the solution. Now, I get that you're then going to want to write that as x minus 2 times x plus 2, and then x minus 2i and x plus 2i. Okay? But we always start with x minus. Everybody got that? So, I told you I'd stab my eye with a spoon if you tried to factor x squared plus 4. But if you factor it to like that, well, then I'll be smiling. I'll be like, okay, I got you. Yep. You know what factors to imaginary solutions. Good for you. Yeah. Be very impressed. Flip it over. warm on days like today. You're doing the fundamental theorem of algebra. You're gonna burn some calories. How many complex solutions? Would you believe it that I've had years where I've had multiple people get that wrong on the test? Folks, you do that, like, we're having a conversation with mom and dad, okay? Don't do that to me. Positive real. None. There are no positive real. P of negative x. Is 8x cubed going to change? So negative 8x cubed plus 1. How many sign changes are there in that situation? There is one. There's one negative real. So how many total real? One. There's only one, and it is negative. That tells me there's how many imaginary? Dos. Sweet. I look for my rational roots. I've got p's over q's. P's would be plus or minus 1, plus or minus 1/2, plus or minus 1/4, plus or minus 1/8. Those are my rational root choices. If you'd like to go ahead and do the rational roots theorem and plug stuff in, you could go right ahead and do that. I'm going to use a factoring method. Anybody know what factoring method that is? Sum of cubes. Still up there on the board. We know how to factor this because you're excellent at factoring. What do you multiply 3 times to get 8x cubed? 2x. What do you multiply 3 times to get 1? We square the front. We square the back. We multiply the 2 together for the middle. And how do the signs go? Yep. Very good. This one is the same as how it starts. The last one's always positive. The one in the middle is opposite. Well, that tells me right away exactly what one of the solutions is. What is one of the solutions? Negative 1/2. That confirms with what we thought because it says that it will be negative and it will be real. What do we know about the other two? They will be imaginary. This does not factor, so how do I go about it? Quadratic formula. Negative b plus or minus the square root of I square b to get 4 minus 4 times a is 4 and c is 1 divided by 8. What do we get underneath that square root sign? What? Negative 12? What should we extract out of negative 12?
The imaginary part of it.
Yep. So a negative 4. We'll write the square root of negative 4 as 2i. What are 2, 2, and 8 all divisible by? 2. So I divide them and I get 1 plus or minus I roots of 3 over 4. We have our other two solutions, which are imaginary. Ready to write this in factored form? It's no big deal. It's just going to look like this. P of x is equal to x minus negative 1/2 times x minus 1 plus I roots of 3 over 4 times x minus 1 minus I roots of 3 over 4. That's not quite exactly right. We just have to make one more subtle change. If I multiply these pieces out, does everybody agree I need to come up with an 8x cubed? But right now, if I multiply x times x times x, I just get x cubed. So in order to just complete this theorem right here, it says there can be a coefficient out front. If we need to come up with an 8x cubed, then we're just going to put that 8 out front. So the factored form is 8 times x plus 1/2 times x minus 1 plus I roots of 3 over 4 times x minus 1 minus I roots of 3 over 4.
So where's the A coming from?
The 8?
Yeah.
X times x is x cubed, agreed?
Yep.
We need to come up with 8x cubed. And if you notice here, look at how we factored this. 2 times 4 is our 8, right? It gets lost in the quadratic formula. So we just put the 8 back out front. Talk to the person next to you. How confident are you in this? 1, I'm completely lost. 5, I could test on this tomorrow. Go.
Yes. So you want us to like do plus instead of minus minus?
No, I thought you just said.
It doesn't matter. If you wrote x minus a negative 1/2, I give you full credit. If you wrote x plus 1/2, I give you full credit. You're going to understand why I'm doing that when we get to the back page. That'll make sense. I'm trying to set you up for the last piece.
Wait, Mr. Vince?
Yes.
Are we gonna have to be able to do factor and stuff on the test?
You should be able to write something in factored form if asked. But you should see, you'll see why I'm doing that in a second. You guys, the whole factored form piece, you're going to see why I'm showing you that when we get to this back page, okay? You're doing a really good job, you guys, okay? Way to go. Again, this isn't necessarily easy, okay? But, again, people do very well in this test when they put the time and the effort in. It's a great opportunity to get an A. Complex, positive real, negative real, total real, imaginary, irrational root choices, your solutions, and your factored form. Again, this is what you can expect to see on your test. And yes, I give you points for each one. Obviously, the solutions is the largest part of this score, but each one of these problems I score out of 8 points. Okay? So, how many complex solutions are there? 3. Positive real, I look for the number of sign changes. How many sign changes do I have? 3. So there's 3 or 1. Okay, so I can subtract 2 there, so I do. P of negative x, I get a negative 2x cubed, a minus 13x squared, a minus 26x, and a minus 10. So there are no negative reals, so we should not try any negative options if we need to. So how many total real are there? 3 or 1. Notice I chose 3 or 1, not because I subtracted 2 from 3, but rather because I combined those two. All right?
Would it be 2 or 0 for imaginary?
Very good. So we'll go through that logic. Brecken has beat us to it. Suppose that there were 3 complex and all 3 were real. That would leave us with 0 imaginary. Suppose we had the other situation where there wasn't 3 that were real. There was only 1 that was real. Then there would be 2 that would be imaginary.
Can you just explain that one more time?
Yes. We know there's a total of 3. If all 3 are real, then none of them would be imaginary. If only 1 of them was real, then 2 would have to be imaginary. These 2 will always add up to that 1.
I think it was just confusing me because there's no negatives, but I'll figure it out.
I list my rational root choices. I have 1, 2, 5, and 10. I have 1 and 2. It's definitely going to be a few options here. Plus or minus 1. Plus or minus 1/2. Plus or minus 2. Plus or minus 2 halves. 2 halves is the same as 1, isn't it? So I'm good to go there. Plus or minus 5. Plus or minus 5 halves. Plus or minus 10. plus or minus 10 halves. Well, 10 halves will be the same as 5, won't it? So I think we're good. Does it factor? Kind of a trick question, right? We've learned now everything factors, doesn't it? Everything factors. Does it factor in a way that you can see? Absolutely not. No, I can't see it either. Time to use rational roots theorem, huh? What would you like to guess?
1.
1? 2 minus 13 is negative 11, plus 26 is 15, minus 10 is 5. Nope. We could try 1/2 or we could try 2, okay? What do you want to try? Okay, we'll try the 2. 2, we got 2, negative 13, 26, negative 10. Hopefully Mr. Gens is a nice guy here. We'll see. Depends on who you ask this time of year. Negative 18. Negative positive 6, 12. Oh, it didn't work, did it? Should we try 1/2 or should we try 5? What do you want to do? Try the half?
Yeah.
Just give it a shot?
Yeah.
We'll try the half.
Why don't you just try it?
Because we know that there are no negative solutions.
Oh, yeah, you're right.
We drop the 2 down, we multiply it by 1/2, and we get 1. Add, we get negative 12. Add, we get, or multiply, we get, add, and we get 20, multiply, and we get, oh, I like that. Yeah. Isn't that nice?
Yeah.
All right, we got a solution, 1/2. That's my one positive real. I could have 2 more, or they could be imaginary. I guess we'll have to see, because what is left over is 2x squared minus 12x plus 20 is equal to 0. Does that factor?
Probably.
You could take out a 2. So 2 times x squared minus 6x plus 10 is equal to 0. Does x squared minus 6x plus 10 factor? No, it doesn't. So
No.
what do we do? Quadratic formula. Fortunately, we're really good at that now, aren't we? And quadratic formula makes Nina very happy. She loves the quadratic formula. 6 plus or minus the square root of, we square b to get 36, minus 4 times a is 1 and c is 10, all divided by twice the a value. Ooh, I like how this worked out. 6 plus or minus the square root of negative 4. What is the square root of negative 4? 2i. Are those all divisible by 2? Yeah, so you've got 3 plus I and 3 minus I, right? Or 3 plus or minus I. Cool. And so we can see that sure enough, this is your one real solution that is positive. We have no negatives. We have a total of 1 positive real. We have 2 that are imaginary, and the one that we listed is sitting right there. That's a really good deal. Let's write it in factored form. We have p of x is equal to x minus 1/2 times x minus 3 plus I times x minus 3 minus I. Anybody want to guess the number that should go up front?
Do you have to put parentheses around those? 3 minus I, 3 plus I?
Well, you need to make sure in the end it would end up being a minus 3 minus I and a minus 3 plus I. So if you wrote it like that, then you're okay.
Perfect.
All right, turn to the person next to you, say, you're almost there, you've got it. Two problems left. These are easier than what we just did. Now we're going to go backwards. We're going to start with the solutions, and we're going to write a polynomial. We're going to write p of x. It has solutions of 4 and I. Well, if 4 is a solution, then what binomial should I put here? x minus 4. Sweet. If I is the solution, well, wait a minute. What is that thing about imaginary numbers? They must come in pairs, right? So if I is the solution, then so is negative I, isn't it? So I can't just have one. I got to have the conjugate as well. So I'm going to have an x minus I, and I'm going to have an x minus a negative I. Again, it's always minus. Now, if you want to turn it to plus there, you sure can. So what we want to do is we just want to multiply this out to come up with a new polynomial. And when we do, I always encourage you to start with your imaginary parts first. The x minus I times the x plus I. Let's deal with the x minus 4 later. Let's start with this now. X times x is x squared. Whoop, I'm sorry I wrote a 1 there. I ate a bowl of stupid for breakfast today. X times I is xi. Negative I times x is a negative xi. And negative I times I is a negative I squared. And what do you notice happens? Yeah, it turns out that everything that's imaginary should disappear. And we get x minus 4 times x squared what?
Plus 1.
Plus 1. Now we just multiply that out and we're done with it. P of x is equal to x times x squared is x cubed. Negative 4 times x squared is negative 4x squared. X times 1 is x. And negative 4 times 1 is negative 4. And that polynomial has the following solutions. The other day when I gave you guys a checkpoint yesterday, it was to the 4th degree. You had solutions of 2, 2, 3, and 4. That's how I started the problem. I started x minus 2 times x minus 2 times x minus 3 times x minus 4. That's how I began. So that I could come up with something that worked out the way I wanted to. Our last example, write an equation for a polynomial with solutions negative 3 and 4 minus 2i roots 3. Tell the person next to you right now, what do you know about this already? Go. Okay, Brecken, here's where I really need BK. Here's where I really need you to focus on this to make sure that we aren't making a mistake from before. Because you asked about the plus and the minus piece.
Yes.
I just want to make sure you see. Does everybody see, first of all, that we start with an x plus 3? Okay? And then we know that if 4 minus 2i roots of 3 is a solution, then so is 4 plus 2i roots of 3. So when I write my answer, or when I write it out in factored form, I still write x minus each time. I don't change that sign. I change the other sign. Okay? It's not an x minus and x plus. It's a 4 plus and a 4 minus. That's the sign you change. So now, as we write this out, I have an x plus 3 times x minus 4 plus 2i roots of 3 and an x minus 4 minus 2i roots of 3. Looks kind of icky, doesn't it? Fortunately, you're really intelligent. Just think about how hard this class would be if you weren't so smart. I got an idea. Let's multiply those together first. And we got confidence in the last problem that if there's any imaginary part, it should end up just going away, right? So let's see it take place. X plus 3 times, and I multiply. And I'm going to be careful because I know in this situation, I very easily can make a mistake. X times x is x squared. X times negative 4 is negative 4x. X times negative 2i roots of 3, negative 2xi roots of 3. First time in your life you've written negative 2xi roots of 3. Looks a little weird. That's okay. We know it's going to go away anyway, right? It's going to disappear. We move on to negative 4. Negative 4 times x is a negative 4x. Negative 4 times negative 4 is a positive 16. And negative 4 times negative 2i roots 3 is a positive 8i roots of 3. Got my last one here. 2i roots of 3 times x is a positive 2xi roots of 3. Hey, I like that. And then I get 2i roots of 3 times negative 4. There'll be a negative 8i roots of 3. Ooh, I like that too. And then this is where people probably make the mistake. 2i roots of 3 times negative 2i roots of 3. 2 times negative 2, negative 4. I times I squared. Root of 3 times the root of 3. Root of 9, which is 3. Everybody see that? I squared is negative 1. So that will change the final answer to positive 12. Devin? Let's do it again. Ready?
Yeah, I'm ready.
Okay. 2 times negative 2.
Negative 4.
I times I squared. Root of 3 times root of 3, 3. So I squared is negative 1 times negative 4 will be 4 times 3 is my 12. Got it? All right. Hey, it's Christmas. What happens? This guy is gone with this guy, and this guy is gone with this guy, and then we got a bunch of stuff that we can combine together. I have my x plus 3 times x squared is gone. Minus 4x and minus 4x, that's a minus 8x. And then 16 and 12, that's 28.
Wow.
All the imaginary parts went away, didn't they? Now we just multiply that out, we're done. P of x is equal to x times x squared is x cubed. X times negative 8x is negative 8x squared. I have a 28x. I move on to my 3. Boy, I remember doing this in Miss Kruger's class. Uh, 3 times 28, that'll be 84. I remember that because that's Randy Moss. X cubed, gone. Minus 5x squared, gone. 4x, gone. 84, Randy Moss. That's the fundamental theorem of algebra, folks. I think it's super cool. I love it. Hey, tell you what, because this is challenging stuff, I'll give you a full day to work on homework tomorrow. How does that sound? Sound good? Now, when you work on this assignment, please understand the following. You might do a problem and say, hey, that worked out just fine. You might get to another problem like, this isn't working out for me. You might have to move on to a next one. See what I'm saying? Yeah. So don't necessarily assume that, say, problem 6 is harder than problem 3. Okay? It might be the other way around. But that's where you're at. If you're behind in your homework, tell you what, you can have Saturday, Sunday, and Monday to work on it as well. And for those of you who are all caught up in your homework because you are on top of life, I'll get you your study guide right now. Even more so, the study guide will be completely optional. If you do turn it in, I'll give you 1 point towards a problem that you did wrong on your test. Should I start requiring the study guide?
No.
Or do you like the extra credit?
Yeah, don't do this.
This will buffer, right? Even though it's 1 point, it's like still a point. Still a point. Every point matters. So, who are we picking this weekend between the Vikings and the Ravens?
I literally just told you all that.
Whoop. Vikings or the Ravens? Who are we picking?
Did I not show you my
Depends on how Lamar does.
The Ravens have nobody on the injury list, not a single person.
No, not anymore. Yeah, Lamar.
Yeah,
back.
the whole team is.
Everybody's back.
They have nobody on the injury list.
Who did they play tonight?
They play all night. It's not tonight.
Oh, who did they play? Oh, they play us?